everyone. My name is Fatemeh and I came from University of Massachusetts at Dartmouth, and my advisor he's from ECE, Professor Fiondella, and we are working on resilience engineering. And about the resilience engineering, we are talking about a system, and it can be anything, and then we are going to define the performance for that system, which it varies domain by domain. And we are saying the resilience, it is the performance, it is like that, the 4 steps that we have. It is working, then some failures is happening, then again after some fixing stuff, we can have the recovery for the system and adapting part. But what is the problem here, which is a time series problem? We want to know how and when the system can be recovered and to which level of the performance can be recovered. For example, it can be equally to the previous step, to the previous performance that it had, or it can be below or above. But we know that in the real systems, it's going to have some more failures and recoveries, again, some shocks and recoveries. So in this poster, you can see that I'm proposing the transfer function, which is an advanced time series model, and I'm comparing my results with the previous state of the art regression with interaction, and I'm comparing the results through 3 different splits, and I chose specifically the 1980 US recession data because it already had multiple shocks, and I could see how my model can outperform the previous models. So we collected 10 covariates that we could understand they have influence on the number of the job in the US. So in this specific problem, the system is the economy of the US and the performance is number of the job. So here you can see for the 3 different splits, the bold rows, they are showing the model that outperformed the other one. And in the all the scenarios, the transfer function, which is an advanced time series model, could outperform the other ones. And why it happens? Because we know that in every single time step that we are considering, whatever it is happening, it depends on the previous steps that we had. So here in these problems, the time series model could outperform the simple models like the interaction with the interaction regressions. And to be fair, for every single split and each model, we did the feature selection for that specific model for that specific split, to be fair, and the comparison it is interpretable. And you can see in the 70-30 split, 70% for the training, 30% for the testing, the interaction with regression did the underestimation in the part that it didn't see it before in the testing part. And it is important for us because sometimes even underestimation can be equally dangerous to overestimation. So we need something that can follow the trend completely. And why not? I can continue? And why we can't go through deep learnings? Maybe someone comes to us and asks, okay, why not LSTM, GRU, which they are advanced time series deep learning model. But first of all, we can't have all the time enough data points for going through the deep learning approach. And second, sometimes we need a model that it is interpretable for us. So we need to go through some ideas, some approach that at the end the results are interpretable. But the whole idea of the resilience engineering, it is for us understanding how and when the performance can be recovered and to which level. So yeah, that is the whole idea of the paper. Thank you.